Hello, today we are going to be talking about lesson 2 in our ratios and proportions unit. So here we've got our proportions. You'll notice that I've reorganized all of the rational numbers unit into one tab there. So let's go ahead and take a look. Last time we did unit 2, lesson 1, ratios and rates. Today we're going to do constant of proportionality. So go ahead and get a copy of the slides. Then we're going to zoom in, make them easier to read. Oh, it would help if I went to view. Zoom. So let's go ahead and read through this. Let's go ahead and put in your name. Put in the date that you watch it and the period that you watch it. Actually, I'm going to zoom out just a little bit so we can see everything that's in there. Two quantities are proportional if the ratio between the quantities is constant. So that's our big idea. Before we talked about what a ratio and a rate was, two things are proportional if the rate is always the same or if that ratio is always the same number. So let's take a look at this. Mario travels 180 miles in 2.5 hours. If Mario travels at the same rate, how far can Mario travel in 5 hours? So if we double the time, we should double the distance. So we can do 180 times 2, that's 360 miles. Alright? Now we could have actually calculated his speed and divided 180 by 2.5. And then we could set that up as our proportion equation, which is something that we should do and check out. I want to grab a drawing tool here to make that a little bit easier to see. So we could have done 180 over 2.5 equals our unknown mileage over 5. And we're going to use this proportion equation when we have fraction equals fraction a lot. Alright? So we could have used this model and we could have done 180 divided by 2.5. And then to get rid of this divide by 5, well, multiply. Because the opposite of division is multiplication. So if we multiply by 5 here, that's the same, and we do that on both sides. These cancel and get 2, and we get 2 times 180, which is our 360. So, using the information about Mario's rate, we can complete the table. Alright, so for 2.5, we had 180. For 5, we had 360. If we go up another 2.5 hours, we're going to go up another 180, and that's going to be 540. If we go up, then that's going to be 720. And we're just adding, every time we add 2.5 here, we're adding 180 here. So we have 900 miles there for 12.5 hours. How many miles can Mario travel in 1 hour? Well, that's actually finding our rate of speed, and that's doing our original division. So we can do our 180 divided by 2.5. We can move our decimal and think of 25 going into 1,800. Or we could do any of these other ratios, so we could do 360 divided by 5, or 720 divided by 10. This is the easiest one to do and the easiest one to see what the answer is, but the ratio is the same for all of them. So let's go ahead and just do the one that is easiest for us to do, and we'll say 720 divided by 10 equals 72 miles per hour. So the nice thing is if the rates are all the same, it doesn't really matter which one we use. I'm going to clear up the work here. The constant of proportionality is the value of the ratio of the two proportional quantities, represented by the equation y equals k times x. Okay? So, where y represents the y values in the table and x represents the x values in the table. So our k value is our y divided by x. Right? Examine the table below. Describe the patterns that are true. So let's look at this. This is going up by 1s. This is going up by 12s. Our ratio of this divided by this, 12 divided by 1 is 12. 24 divided by 2 is 12. 36 divided by 3 is 12. 48 divided by 4 is 12. And 60 divided by 5 is 12. So the ratio is always the same. How do we know that the number of feet is proportional to the number of inches? Well, the ratio is always the same. By using x for the number of feet, how do we write y, the final number of inches? So we say y equals 12 times x. So whatever our number of feet is, we have to multiply that number by 12 to get our number of inches. Now we go on to page 2 here. So y is our output. K is our constant of proportionality. Oh, it would help if I type that right. Proportionality. And then our x are our inputs. Okay. And or new vocabulary that we're talking about that we're often going to be using related to functions. So y, we can think of our y values on our graph, and x can be represented as the x values on a graph or on a table. Now let's apply this under this concept to this new problem. Okay, while training for a marathon, Keith's watch reports how many calories he burns at each mile marker. The data is shown below. But is the number of calories proportional to the number of miles? So we're going to look at the ratio. Our first one is 117 over 1. I'm going to grab the little text tool over here. Our next ratio is 234 divided by 2. And that is also equal to 117. I'm going to put equals 117. Come on, text tool, let me write. Equals 117. And I'm going to click over here. Then our next one was 351 divided by 3. And that's going to be 117. Then we're going to do 468 divided by 4. And that's going to be 117. And then we've got 585 divided by 5. And that's going to be 117. So yes, we can say that yes, it is proportional. The ratio is always 117. Well, for each mile, he burns 117 calories, so we're going to do 117 times 7.5. All right, so let's go ahead and figure out what 117 times 7.5 is. And that equals 877.5 calories. What is the constant of proportionality? It's 117 calories per mile. Now I'm going to use that division, so you could either write it that way, or you could write it calories per, with the word per mile. You could even say 117 calories for each mile, but we need one phrase in there that tells us that it's a ratio. Write the equation to explain the relationship between the number of miles and the calories burned. Now, rather than using y and x, I might use m for miles and c for calories. So c equals 117 times m. Or you could write y equals 117 times x, where y represents miles and, where y represents calories and x represents miles. I think letters that make sense for our problem make it easier to remember what our problem is about. If you just use x and y all the time, which granted are the most popular in math, it can be confusing because you have to remember what the x and y refer to. All right? Now let's check to see if these are proportional. All right? So 6 divided by 1.5, well, that's 4. 16 divided by 4, that's 4. 22 divided by 5.5, that's 4. And 30 divided by 7.5, that's 4. Yes, it's proportional, and our constant of proportionality is 4. 3 divided by 2 is 1.5. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. And 12 divided by 8 is 1.5. So my constant of proportionality is 1.5. Let's look at this one. 36 divided by 3 is 12. 60 divided by 5 is 12. 72 divided by 6 is 12. And 96 divided by 8 is 12. So my constant of proportionality is always the ratio given y over x. In this case is 12. So go ahead and summarize what you've learned. What is the constant of proportionality? What does it mean for something to be proportional? How is that connected to ratios and rates?